In this tutorial, we are going to learn the idea behind continuous backup words. Let's begin. In continuous backup words, we try to predict the center word using the nearby words. How? Let me show you. Let's say we have these three sentences in our corpus. So the very first step will be we have to concatenate all these sentences so that it will become one single sentence. This is the first step. And the second step will be we have to choose a window size. Let's say the window size is 1 in this case. What is the use of this window size? Let me show you. If the window size is 1, then in your first sample, these two words, the and is will be your input words and product will be your target word. Similarly, in the second sample, product and really will be your input words and is will be your target word. This is the use of window size. What if window size is 2? Then how the sample would look like? If the window size is 2, then these four words, the product really good, will be your input word in the first sample and is will be your target word in the first sample. This is how it would look like. Alright, now let's go step by step. The very first step is we need to concatenate all the sentences so that it will become one single sentence. And the second step is we have to choose a window size. Let's say window size is 1 in this case. And the third step is we need to get 1-hot encoding for each and every word. Let's do that. To get 1-hot encoding, first we need to take all the unique words from the corpus and we need to give some unique index value for each and every word. Then simply put 1 in the corresponding index position and put 0 in the remaining places. That's it. This is the 1-hot encoding of this corpus. And the fourth step is we need to prepare training data. Let's see how to prepare training data. If the window size is 1, then in the first sample, these two words will become the input words. The and is will become the input words. And product will become the target word. So this is how we have to prepare training data. In the second sample, these two words, product and really will become the input words and is will become the target word. In this way, we have to prepare training data. Let's say this is our training data. And the final step will be training the model. Let's see how to train the model. To train the model, we need these two information, 1-hot encoding and the training data. Let's take the first sample where the and is are the input words and product is the target word. Let's take their corresponding 1-hot vectors and let's feed it into the model. If you look at the model architecture, it is just a 3-layer neural network. One input layer, one hidden layer and one output layer. If you look at the input layer, it has 14 neurons. Why it has exactly 14 neurons? Because the input dimension is 1 cross 14. That is why it has 14 neurons. And in the hidden layer, we have 5 neurons. It is not necessarily to be 5, it could be any number. But I want the word embedding dimension to be 1 cross 5. That is why I kept 5 here. And in the output layer, we have 7 neurons. Why? Because there are totally 7 unique words in the corpus. That is why we have 7 neurons in the output layer. That's it. If we feed this input vector to the model, we will get the predicted value. Then we have to compare the predicted value with actual value in order to get the loss. Based on the loss, we have to backpropagate through all the layers and we have to update all the weight parameters. Finally, at the end of the training process, here we will get a weight matrix which is of size 5 cross 7. It would look like this. This is the actual word embedding which we are interested in. Now what we can do is we can take the 1-hot encoding of the corpus and we can multiply it with the transposed version of this weight matrix. We will get the actual word embedding for the entire corpus. This is the idea behind continuous backup words. In the next video, we are going to discuss about skipgram. Let's see.